Well, a year ago, I mean, building an AI agent took, weeks, right? And just thousands of lines of tangled code. But today, you can actually do it with just 2 Python packages in less time than it takes to brew a cup of coffee. Welcome to today's deep dive, by the way.
Yeah, the shift is just, it's massive. And today we are unpacking this source called Notebook Zero, the quick start, which is from Lazo UK's open source GitHub ramp-up repository.
Right.
And our mission here is really just demystifying this new Microsoft Agent Framework, or MAF, and showing you just how clean and simple it has become to get these agents off the ground.
It really is like just 2 packages. You've got Agent Framework for the core mechanics and then Azure AI projects to hook into the cloud infrastructure. But before you even build the AI's brain, you really have to lock down the foundation.
Oh, absolutely.
Because, I mean, if you have ever coded before, you know that dread of accidentally hard coding an API key right into a script. It's basically the digital equivalent of like leaving your house key under a very obvious doormat.
Right,
Yeah.
exactly. It's a massive vulnerability. But the notebook solves this really elegantly by importing something called default Azure credential.
Okay, so how does that work?
Well, think of it like a VIP bouncer for your code.
Yeah.
Instead of you handing over a ticket, the exposed API key,
Yeah.
the bouncer just checks your system's hidden ID badge. It pulls your endpoints and models directly from environment variables that are just stored locally on the machine.
Oh, I see. So if it's pulling from the local environment, I'm guessing that means moving from like a local laptop to a massive cloud server is completely frictionless.
Spot on. Yeah, because the code itself never actually changes. Whether you run it locally or in the cloud, authentication is just seamless and secure.
That is so cool. Okay, so with the vault secured, we start building the agent.
Right.
You initialize a Foundry chat client, which connects you to the model, and then you bind it to a persona, right? So you give it a simple instruction like, you are a haiku poet.
Yes, and the notebook actually shows 2 ways to spawn this agent, which is interesting.
Yeah, I wanted to ask about that because method A uses the standard agent class, but then method B uses this shortcut like client.asagent. Honestly, the second one just looks like a minor developer convenience. I mean, why bother including both if they do the exact same thing?
Well, it really is about catering to a Pythonic style, as developers call it. It means it just reads more fluently, like plain English, and it requires fewer lines of setup.
Oh, so it's just a preference thing.
Exactly. If you already have your client configured, that agent shortcut just lets you spin up a persona instantly, without having to re-import the base classes. It keeps your code super clean.
Okay, got it. So we have our poet. Now, to make it talk, the notebook asks it a simple question, like, what is life? And I have to push back here. The command used to run this is asynchronous, uses await agent.run.
Yeah, that's right.
For a basic text prompt, I mean, asynchronous code just feels unnecessarily complex, doesn't it?
I get that. On a single simple prompt, you could definitely argue it's overkill. But you have to remember, whenever you ask an AI a question, you are making a network request over the internet.
Right, and that creates latency.
Exactly. And if you use standard synchronous code, your entire application just freezes while it waits for the AI server to think and reply.
Oh, wow. So it literally locks up the whole system.
Yes. So by forcing asynchronous architecture by default, the framework ensures your program can just keep running background tasks during that wait time. It's crucial for when you inevitably scale up to, like, multiple agents talking at once.
Oh, I see. And because async frees up our system while waiting for the network, we can actually use that idle time to actively stream tokens to the screen as they arrive, right? Rather than waiting for the whole response.
Yes, and that is the real magic for the user experience. Use an async for loop with stream equals true, and the framework hands you each word the millisecond it's generated.
And the notebook specifically calls out using Python's flush equals true command to make this happen, which I thought was fascinating.
It is, yeah.
Because normally computers hoard data in this hidden buffer to save processing power, right? And then they spit it out in big chunks. But flush equals true overrides that efficiency.
Right. It forces the computer to bypass the buffer entirely and just print every single letter immediately.
Yeah. It creates that cool ghost typing effect instead of, making you stare at a blank terminal wondering if your code just broke.
Exactly. It proves the system is actively working, which is just so crucial when you're dealing with these complex AI responses.
It really shows that building robust, secure AI doesn't require a mountain of boilerplate anymore. I mean, MAF handles the heavy lifting, from the security bouncers to the async streaming.
The initial barrier to entry is essentially just gone now. You can focus purely on what the agent should do rather than, how it connects.
Which leaves you with an interesting thought to explore as we wrap up. I mean, if giving an AI a customized brain and a distinct persona is this effortless today,
Which it is, yeah.
right, what are the implications when we move to the next step and start giving these exact same agents hands to manipulate the outside world using tools?